All right, practice problem, let's look at. So it's telling us that this person from Italy ran 18.84 kilograms in 1.000 hours, I'm assuming, world record time. And it's telling us that kinetic energy was 694 joules and is asking for the mass. So we're using the kinetic energy formula, right? Which 1/2 times mass times velocity average squared. But what did they do to that formula?
Yeah, you had to isolate mass.
Yeah, well, you just need to put a different unknown on the other on one side.
Yeah.
Do you exactly what you said, but I just said it a different way. Simple way that makes sense to me. All right, so what they did is they're going through and they're taking 2 times the kinetic energy divided by velocity average squared. But for velocity average squared, you had to have the change in position over the change in time. And then after that, it did something else. And then at the end, they plugged that in. Now, what mode do your calculator need to be in?
Math mode.
Math mode. I like that, math mode. Okay, normal, right? Radian. We aren't doing any degrees here, are we? Well, I hate to tell you, but my CP class is now doing degrees, so it might be changed into that. So please make sure you have normal and radian on your calculator. And so for this one, we just plug this in. So I think everybody's done that. I'm going to come by and check you. I'm going to plug mine in really quick. Please have yours on. Radian. Well, right now, ma'am, I'm doing the problem on the bottom of 161, the sample problem that we just started looking at. And I just want to check to make sure you know how to put it in your calculator, so I'm going to come by and look. All right, if you have it, I'm coming by. You should already have it in. All right, sir. What are you doing there? I don't know. All right, sir. Okay, Gabriel?
Give me a second.
Oh, okay.
No. Why is it? Oh, it changed the meter for a second. Why would it do that?
Thank you, ma'am.
Oh, I got it.
Okay.
It's on the paper. That's what the thing says.
Here we go.
What do you get whenever you did it? Because I got something different whenever I did it on my own too.
Okay, that's because I changed it to seconds and meters.
The answer is 55. Don't know how.
Because they changed it to seconds and meters.
You see it?
Yeah, I know. What?
Kind of warm.
It'll show you.
Should have brought that. I'll bring your jacket every day.
Oh, did you plug in the?
Yeah.
You just had to plug it in.
So right now, we're on page 162.
No sugar, no
Have
calories.
yours in your calculator.
Very shitty though.
It doesn't work. It's mess. But anyway, I said mess. I'm proud of myself. It's okay. It's the one that nobody wants, and it seems to find its way to other
I
tables.
didn't even check mine. This is the one time I actually did it.
I'm sorry, Brooklyn. May I stop for a second to go look at your glory? Thank God. Okay.
Where's the space car?
Is everybody good? Every time you look at the sample problem, the best thing for you to do is to make sure, can you put it in the calculator? So let's go to the next page. All right, so I want you to go through question number 1. I'm going to give you a minute to look at it, see what you can do on your paper, and then we're going to go over it together. I know I haven't posted it yet. We're just going to post it until we get done. I'll get it done. I promise. Let me see your answer, Greg.
For this one?
Yeah, the one that everybody's working on right this second.
I haven't finished that.
Yeah, okay. Start right away. See that section on the outside of that one?
Okay. What am I doing?
Y'all shouldn't be talking to each other. You should be working. It's okay, baby. Sometimes the key sticks.
Okay.
Okay. What is my mass?
8.0 times 10 to the 4.
I thought that was the speed.
What's our kinetic energy?
1.1 times 10 to the 9
That's how
joules.
much it weighs.
Or, yeah.
Okay. What are we looking for?
Speed, velocity. Same thing.
It is. All right. There's your formula. Okay. So you're going to do the square root of 1.1 times 10 to the 9 joules times 2 over 8.0 times 10 to the 4th kilograms. Put it in your calculator and I'll come by and look at it.
Yeah, that's what I got.
Oh, I'm messing up hard.
Now, 165.8312395. Is that what you got?
Yeah.
Let's go to mode. Let's change it to scientific. What is our true answer?
1.7.
1.7 times 10 to the 2nd power. Does everybody see it? Why did I change my mode on this one?
Because you're finding speed.
No, because I have really either really big numbers or really small numbers, don't I?
That's what I said.
What mode did you put in?
I put in scientific. The reason why I changed it to scientific because these are really, really big or small numbers, right?
Oh, it is.
I got 1.7 times 10 to the 2nd power. Is that what you got? You good? Everybody good so far? All right, let's go see about question number 2.
I only have one pencil. Where'd it go?
All right. What is my mass?
Oh, you have 2 mouses. Oh, no, you don't.
It says here, what is the speed of a 0.145 kilogram baseball if its kinetic energy is 109 joules? All right. Is this what you have so far? Okay. We're going to do the same thing again because we're looking for velocity. really big numbers.
No.
So what am I going to do first?
Put it normal.
Normal mode again.
Yeah.
We're going to keep flipping back and forth. Okay? So my answer was 38.77432496. So what would be my answer? 38.8. All right, go ahead, number 3. How many masses and how many velocities do we have?
One velocity for 2 masses. So it'll be the same velocity for each.
It would be. All right, so let's start that first. What's my first mass?
3 grams,
Okay, what's my velocity?
40 meters per second.
Okay, what's my mass 2?
6 grams. Back to being kilograms.
Yes. And how we do that? Move the decimal over, correct? Okay. So I need to do 2 kinetic energies, correct? What's my kinetic energy 1's formula? There's my first kinetic energy formula. What is my second kinetic energy formula?
Same thing with the 2s.
So use both.
When I get my answer, what do I do then? No.
Find out the ratio.
Yeah.
And then find the ratio. Perfect. Beautiful.
Why don't you just? How do you do that in a second?
Well, I mean, it's 3 and 6. That seems logical. Doesn't it?
Or you could just not multiply the second one by half.
But both of them are very good. Thank you. It's just this works out that way because it's twice as much. But what we want to do is we want to do all the math just in case it isn't in that situation.
Don't do 3 and 6
I
now.
was supposed to
You gotta
square.
turn the kilogram.
Yes.
Oh, we are thing. Wait, you don't have to.
Yes, you do.
You do have to put it in kilograms.
I said squared.
Have to square it?
No, you don't have to. You don't have to put it in kilograms. Oh, you don't.
Okay, so
Because they're needed. Has to be in
it's
kilograms.
velocity, and velocity is
That's
always
velocity
meters per second. Okay.
My math.
This here is a
I don't
small
weigh that
number.
much. I don't weigh a
So we
kilogram.
done the scientific method. You should be working by yourself. I have everything up there for you. Please work on that. And then this one, as you can tell, are small numbers, so I didn't do that there. Okay, but they're always meters per second. Yes, because it's, no. Yes. This and this. Okay. What you got?
The wrong man.
The ratio of 2.
What'd you get on? Also, what'd you get? What happened with that? And then did that.
Where'd you get 1,400 from?
Because you squared the each equation.
No,
That's what that thing
it's
says.
just leave this square.
That's not what that thing is.
You're working, Gabriel,
Leave this on.
Austin.
I know, bro, but they know it.
It's square.
So what do you get? What do you get?
Me? I got 2,400. But now it's 2.4 and 4.8.
And then the second.
Oh.
Look at that big hole one more time.
Put in the lab page. So what I did is I changed it because.
That's all we need. Well, for us, they're not all you.
And that's what my number is. So you're waiting at these things, that's what it is. Okay, thank you. So the other thing that I see.
Yeah,
is-
you make sure my notes
wrong.
I'm trying to get this thing.
I mean, you did 4,800 divided by 24.
Well, you will have
Or
to
just
have
half of it.
times
Or
three.
half of it.
It's 20 times how much?
18 kilograms, kilograms, kilograms. And then 40 squared.
Half of it. What do you think? Half.
You get 20 something. You said you got 20 something in a row.
Okay,
You got
so first thing that I see so far,
You said you had 20.
first thing you have to do is you have to change your grams to kilograms, okay? So the only thing I did was 3.0 times 10 to the negative 3. That was easier for me, or you could just move your decimal over.
Negative.
So the way that I did mine was 1/2 times 3.0 times 10 to the negative 3 kilograms times 40 squared, and that gave me 2.4 joules. The next one I did 1/2 times 6.0 times 10 to the negative 3, and that's kilograms, times 40 squared, which gave me 4.85. So then what I did is I took my 4.85 divided by my 2.4 joules, and that gave me 2 to 1, or 2. Everybody good? Fantastic. All right, so let's go ahead and do the next problem, please. Number 4.
You don't know how you do that, but I got 2.
Yeah, I always do that. It's easier. Because then I can't remember the full effort, right? And I just do it that way instead. Okay.
This one, would you need to put it in scientific?
Is it a really large or a really small number?
Where's my number was?
Okay, so the answer to your question is? Okay.
Your answer is yes.
So glad I'm recording your variables.
Did I hear my words?
Yeah. I see you gonna hear it later.
So you're telling her math, right?
Oh,
Focus on that, please.
Here, what are you talking about? Yeah.
That ain't Gary.
Austin's coming up to do it. Go on up, Austin.
Oh, I didn't get that. Nope. Never.
Just do it. You got it. Go ahead. I have faith in you.
I don't.
You are selected.
All right, Austin, you give us all the right answer that you haven't received yet.
I was gonna get the wrong
He's
answer.
received it. He said he and Gabriel agreed they had the same answer.
That doesn't mean it's right.
Okay.
Where's the mark?
See, but it's me and you and
Please, everybody, pay attention to see what you have compared to him. If you disagree, please raise your hand so we can discuss it.
I disagree. Good guess.
Bro, y'all got the same answer.
Is it the right one? Is it the right one, babe? Yes, ma'am. Go to that half minute, so I can put it away slow.
Okay, okay. Give it 2.5 times 6 to the fifth.
You don't round up.
What you get?
No, you write 2.6 now.
I'm gonna see if I get another calculator. I'm gonna find this one thing.
You're doing great, Austin.
Okay, so what he did is he was saying that M is 3.8 times 10 to the 31 kilograms. The kinetic energy was negative 1.1 times 10 to the 42nd joule. And so he's using the velocity formula of square root, 2 times kinetic energy divided by the M, which he got 2.55 times 10 to the 5th power. Very good. Yes. If you'd like. Questions, anyone? All right, let's go to the next page. Over on the next page is another practice problem. What I would like you to do is take a moment, look it over, make sure you understand it, and make sure you put it in the calculator to do the math. Do not skip to the next practice problem. Just look at this first.
There's a lot of variables.
They don't erase that yet.
I won't erase it. I'm sorry.
Okay, you can erase it.
Thank you, ma'am.
No, wait for a while.
I'm not doing it yet, please.
You can erase it. Yeah, I think we're all done.
She is not.
Awesome, next time you hand right back.
So right now you are focusing on looking at the question because I probably will call on you to explain it. Please make sure you're ready. Okay, so let's look at the problem. What is going on there?
There's a block sliding down the side of a pyramid,
Okay,
and you have to calculate its kinetic energy.
God bless you. Good job.
That boy gay.
Wow. So does it make sense on what they're trying to do here?
Yeah.
Okay, what is interesting about this? Why do they have like 1, 2, 3 of the same lines there, and then they solve it at the bottom? What are they doing there? They're just breaking it down, correct?
Yeah.
They're going and simplifying it as it goes down. Do you have to go all the way down to simplify? Can you just put it in the calculator like you're supposed to?
Absolutely.
Did you try that? Did you put just the very first one, 1.37 times 10 to the fourth, and then all of that? And did you get the answer you were supposed to get?
Yes.
I'm surprised because you would have to change your calculator to what?
Scientific.
Degrees.
Oh, it was a 10.
Yes.
Yeah, that's already there though.
No, but I'm trying to make you think critically here. Okay. Here, you have to have in degrees when you're trying to do that. If you don't put it in degrees, what happens?
You go wrong.
It's going to get a wrong answer. All right, flip the page. Question number 1. Let's see what you know. Let's go. Write down your variables and see what you can do. So what you're doing is you're looking at your paper, you're writing down the variables you think it is, and then once you get that done, you're looking at the board to see if yours is right. Or better yet, to see if mine's right. Look back at the problem, figure out where did I get those numbers from. What would be the first question that you would want to ask me?
Why would you put 180?
How are you so beautiful?
180 is flat.
I understand it's flat, but why do you need
But he's doing exactly what I'm asking him
it?
to
It gets you a
do.
zero regardless.
I asked anyway. Still, I wanted to know, and she was right. So he asked a question: where did I get the 180? She said it's flat, 180.
Look at the flat surface.
All right. So then, what formula are we going to use? Okay. What is the formula we're using? What are we looking for? Mass. Okay. Mass equals what? We have friction kinetic. Were we going to use that somehow? Okay. 2 times the force kinetic times what?
Oh, you would use this formula from earlier.
Yes. D. D stands for?
Dog.
Okay. Cosine. Here, Hannah again. Angle. Over what? What are the other 2 things we've got? Velocity final minus velocity initial.
Those aren't squared? Copy goofy.
You're not goofing.
Okay. You're not goofy.
All right. You have the variables. You understood where the variables came from. Now you have the formula. What you're looking for. We don't have to change anything. And the only thing I do is plug and chuck. When you get done, let me know and I'll come by and see it.
You'd rather in the other mode, on number.
Oh my God.
I put it on. So here's the question, that's a good question to ask. Do we have to have it in scientific?
No.
No, because there's not any big numbers, real big numbers, or real small numbers, is there? Okay? What other thing? Are we gonna have it in radian? No, because I have a degree here. So our numbers are 2 times 0.12 newtons, right? Times 45 meters. Cosine, my angle is 180. Divided by velocity final, which is 0 meters per second. Subtract 8.0 meters per second. Is that what you plugged into your calculator?
You gotta square that now.
And squared it.
That's not meters per second squared.
I know. So I'll do this.
There you go. That is
God, I
accurate.
love you. Okay,
What do you do?
what did we get?
0.175. How? What we rounded to?
1.01.
I did 0.17
That's
kilograms.
what I would have said.
Okay. Am I 0 for 2 today with you?
No.
Okay.
it's 2 for 2.
2 for 2. 0.17 kilograms, is that what you got?
Yeah.
All right. Change it out of scientific mode into normal mode, right? And then you probably will have it. Go ahead and do number 2, please.
Make sure you're in degree mode too.
Yes.
He may not look, you know.
You didn't have an degree mode. did you?
There it goes.
Do that one. Excuse me? Did you put the mayonnaise up? Yeah, I put the mayonnaise up. Yes, ma'am, I did put the Band-Aids up. Do you need one? I need one. Sure.
You did say mayonnaise, right?
I hope you put the mayonnaise
You did
up.
the first time. That's what I wanted
I
to
need
make
to
sure.
go get my hair cut.
You wouldn't, yeah, you wouldn't want it to spoil.
Okay. Thank you, Gabriel.
Mayonnaise.
Thank you. I'm so sorry. All right. So, what did we do here?
You gotta do math.
Okay, what did you do?
I honestly, I did for displacement. I took the height of the mountain. I subtracted when it was at that other number, and that gets you 42.
Okay.
42.
And what else did you get? And that's for D, right?
Yeah.
Okay, sure. 42. And what else did you do?
Meters. Where's the meters? The speed is 27 meters per second.
Where's that go?
Velocity final.
Yeah, no,
Yeah.
I have one already gone.
That's what I'm saying. It'll be 0 and that 27, I think.
Okay. Do we have kinetic friction?
We don't got
Do we have angle?
They ain't got nothing.
All right, so what are we using here?
Oh, you must not like my variables you're erasing.
What are we trying to prove here?
The air resistance.
Air resistance. Do we have a formula for air resistance? Have you seen one?
If it's not in this right here, does it work one? We don't know how to do it. Alright, so then that work one.
Can we go to 3?
Let's go to 3.
Let's go to 3.
I like that.
Okay. Well, I'm not doing 2 right now. I'm gonna go on to 3. Sorry, Hannah. All right, so let's see what we got. I think this is got everything we need. It was work, by the way, is what we're trying to find.
Yeah, but we're good. Everything's. I know.
I know you were talking to you. You were having a conversation.
You did 1-1.
Yeah, 101. Okay, so what variables do we have? What is our M?
2.1 times 10 to the.
Uh-huh.
No.
What is our angle? What is our force kinetic? What is gravity? What is velocity final? And what is velocity initial? Okay? We got all that. Find the variables.
Oh, let's all use variables again.
There's your equation. So right now, like the test, here's the variables you need to find. Here's the equation. See what you can do. You get your answer, call me over and I'll come see it.
I don't find it bad.
Yeah. There we go. No, dude. Oh, it did.
Yeah, I just downloaded the memory. It's okay, you use that one. If it doesn't work, you can use this one.
I forgot gravity.
Yes, ma'am, throw this away.
I'm like, well, if I can't get back in here, I can't. I'm never doing that.
Got an answer?
No, because I don't have gravity, and I'm going to have to rewrite all of that.
Well, it's 9.81.
Sweet.
I don't want to erase the bottom.
So do me a favor, just pull it back up and then just go over and insert. It'll take 2 seconds.
Oh, yeah, I got it. No. There's a lot more out there.
Let's see what you got. Okay.
That's what me and Austin got.
Take it on. You got the same thing?
Right here.
She looked at me and was like,
That's like every time she passes my papers and
Look
she's
now.
mad about it.
Ain't nothing gonna change. This is my instant. I'm fine with it. She can say 3 for 3 right now.
I put a lot of work into the trial.
I'm telling you, I tried to understand it a little bit. I ain't understand it, so I just put the number in. But that's my number.
I did the 1 on one top and then 2 on the bottom.
Where you wrong? Is that another one you got?
All three of them got the same thing.
Wait, we can make it 4.
That's not necessary.
All right. Here's the question.
What'd you guys get?
Is this 1/2 over here or is it on top?
It's on top. That's what you have written up there.
I'm asking you in your book. Is it 1/2 on top or is it on the side?
I don't know where you got that paper.
I put it on top. I literally typed in 0.5. I didn't even leave it in a price.
Yeah, even if it was on the side, it's not the point
It,
five.
it, it wouldn't matter because it's on top.
Okay, so if,
It'll give you the same answer whether it's on top or on the side.
I tried that one time too.
yeah, see, I got 5.1 meters. Because I put the 2 on the bottom and the 1 on the top. I think I did it wrong. I think I didn't put the 1/2 on the top. I just put it down on the bottom.
You didn't even put a half, you put a 2.
I put 1 is
Yeah.
given. Shut up. Okay. What answer did you get so I can change mine?
Mine don't make no sense. Like, now that I think about it.
What did you get, Orange?
What happened to this? Is my answer? I'm sticking with
I
it.
like 5.
I don't have that
I
philosophy in
got
this class.
5.4 times 10 to the negative 4.
That don't make no sense for a driveway.
I got 1 point.
How the driveway?
It went
Well,
down the driveway.
How the driveway that long? It's not a negative number. It's like a, bro, that's a decimal. It's a 4-digit decimal.
And see, mine's 5.1 meters.
See that? What did you get?
Then-
Yeah, 5 meters for a driveway.
5.4 times
Can I borrow your calculator since I don't have one?
Absolutely, I don't need it.
I don't need it.
I'm gonna try to unconfuse myself first, and then once I get that done, I can unconfuse you.
You're eating more. I invited you to the movies for free and you didn't come. Now you're being greedy. I also want to share your peanut M&M's.
Already did.
You want to share?
That's like you had
Already shared.
You get it right, you give it right. You get it right. You give it right.
Give me the address. I'll give you.
No, she's across the road.
You do have this in
It's
gradient, right?
Agreed. It wouldn't change anything.
Well, you.
That's what I was
I was
asking.
saying if I put it right
We were good. Me and him knew what we were talking about.
in. We're on a wavelength. Don't forget that.
Yeah, we're.
I can't cry anymore.
So you got 0.75, right?
Huh?
You know what you got.
What number?
Yeah.
I didn't write it down. If it was on that calculator.
Yeah, 5.
Hey, Austin, what we get, bro?
Yeah, 5.73
5.37.
times 10 to the 4th power. And you did 0.5. I'm gonna go with
5.4.
5.4 times 10 to the negative 4.
5.4, yeah.
Don't question science.
I'm questioning that.
Majority of the class got that. You're the odd one out that got it wrong.
Let me see yours.
I don't think my answer's right. I just.
I want to see
that
hers too.
is-
Give me some. No, that's why. No, I already know. I know why yours is wrong.
See, yeah.
No, I don't.
Wrong.
Okay. Take a picture of your work, please.
Oh, one.